All right, let's dive right in. Today, we're talking about the secret language that powers basically our entire digital world. It's called SQL, and it's how we have conversations with huge, massive amounts of data.
You ever stop and think about that? You know, how does your favorite streaming app know exactly where you left off in a series? Or how does that online store keep your shopping cart perfectly saved, even if you come back days later? It kind of feels like magic, right? But it's not.
Well, the secret is this special language. It's designed to do one thing really, really well: communicate with databases. And you can think of databases as these enormous, perfectly organized digital libraries that store pretty much every piece of information you can imagine.
And that language, the one that acts like a universal translator for all this data, is called SQL. It's kind of the hero of our story today, and we're about to break down exactly what it is and, more importantly, how it works. So, what's the official definition? SQL stands for Structured Query Language, and it is the standard, the go-to language for what we call relational databases. Basically, these are systems that organize information into neat tables with rows and columns, a lot like a superpowered spreadsheet.
Now, get this, because this is the important part. The key phrase here is English-like statements. SQL was actually designed from the ground up to be intuitive. You don't have to be some coding genius to get the basics. It's built to feel like you're just, well, asking a plain and simple question.
And this picture shows the whole process perfectly. Just imagine a giant library, that's your database. You write down a simple request on a slip of paper, that's your SQL query. Then you hand that request to the librarian, and that's the database engine. And that librarian knows exactly where to go, which aisle, which shelf, to find the exact piece of information you asked for. It's that simple.
Okay, so what can you actually do with SQL? Well, it's pretty powerful, but we can break down everything it does into three main actions. You can ask for information, you can change that information, and you can build the structures that hold it all in the first place.
So here they are, the three big families of SQL commands. First, there's DQL, the data query language. That's for asking questions. Then you've got DML, the data manipulation language, which is all about making changes. And finally, DDL, the data definition language, which is for actually building the database itself. Let's start with the first one, asking. All right, first up is DQL. This is the one you're going to use 99% of the time. Its whole job is to just fetch data. And the absolute star of the show here is one single command: select. This is how you ask that librarian for a specific book, or say a whole list of books by your favorite author. And just look at how readable that is. Select the employee's name from the employee table where their age is greater than 20. See? It does exactly what it says on the tin. You're not writing crazy complex code, you're just writing out a clear instruction. Okay, on to our second big action, DML, or data manipulation language. This is how you change the data that's already in the database. Think of it like adding a brand new book to the library's collection, that's an insert, or maybe correcting a typo in a book's title, that's an update.
Here's a perfect example. We're telling the system, insert into this table called XYZ, and in the author and subject columns put the values Suno and DBMS, and just like that, boom, you've added a new piece of information to the library.
And last but not least, we have DDL, the data definition language. I mean, before you can add any books to the library, you need bookshelves, right? Well, DDL is how you build the structure of the database itself. You use it to create the tables that are going to hold all your data. And the main command here is create. And here we are, literally building a container. We're saying create a table called employee. Then we define what goes in it. We're telling it we need a column for a name, which will be text, a column for an email, also text, and a column for a date of birth. We're basically drawing the blueprint for our data. So now we've got the basic building blocks down: asking, changing, and building. But let's get to the really cool part. This is where SQL goes from just being a simple tool to a seriously powerful engine for discovery.
So here's the thing. Data hardly ever lives in just one neat little box. You might have a list of all your customers in one table and a completely separate list of all their orders in another. By themselves, they're just lists. But what if you could connect them? This is where SQL just absolutely shines. On the left, you've got two totally separate tables. But using a simple SQL command called a join, you can instantly create the view on the right, a single unified report that shows you exactly which customer bought which product. This isn't just data anymore, this is intelligence.
And a join is exactly what it sounds like. It joins rows from different tables together using a column they both have in common. To go back to our library analogy, this is like asking the librarian to pull a customer's main file and all of their checkout history and lay them out side by side so you can finally see the whole story at once. But what if you don't want to see every single record, right? What if you've got millions of rows of data and you just want the big picture? For that, SQL has these awesome tools called aggregate functions. One of the most common ones you'll see is called count. It's so simple, but it's incredibly powerful. It does just one thing. It counts how many rows in a table match what you're looking for.
And boom, just like that. With one little command, you can turn a massive table with thousands of individual orders into a single, useful number. Instead of scrolling forever, you instantly know you had 5,472 orders this month. That one number could drive your business strategy for the next quarter. That's the power of aggregation.
So let's do a quick recap. SQL is the language for talking to databases, period. It lets you ask for data using select. It lets you change data with things like insert and update. You can build a whole structure from scratch with create. And most importantly, you can combine and summarize data using things like joins to turn raw information into actual powerful insights.
You know, we've really just scratched the surface here, but you now understand the fundamental grammar of data. So the only real question left is, now that you have the power to ask almost anything of all this information, what questions will you ask first?